Sorry guys, forgot to hit record. This is 5, review number 5. Okay? But if there's more than 2 capital letters, like say this, okay, then UC3, go to table E. You have a polyatomic. Now, this is, of course, for those of you that have finished organic chemistry, when the molecule is not organic, when there's no carbon going on, right? Because if it's organic, we know we have to use table R for functional groups or table Q for the hydrocarbon thing. But if you see 3, you have a polyatomic, you're going to want to look at table E. Okay? So before you name it, you're going to ask yourself, how many capital letters? We're good with that? Okay, we're going to go here. If there are only 2 capital letters, you are going to determine what they are. Is it a metal and a nonmetal, or is it 2 nonmetals? Because you name them differently. Is it ionic, or is it covalent? That's the next question you ask. Is it a metal to a nonmetal, or is it nonmetal to nonmetal? Because again, depending on what it is, you have to use different rules to name them. What is this one? Metal to nonmetal. So let's go through the metal to nonmetal rules. You name the metal. I heard somebody say it. Copper. Okay? That's copper. You name it, copper. Then, whenever there is a metal, you have to look up your metal on the periodic table to see how many charges it has in its box. How many oxidation states? 2. Okay, that's a problem. That's the hardest one. I'll show you. For those people that don't know what the heck's going on and what you look at, you look up your metal. If there's more than 1 oxidation state, you add parentheses after its name. If not, you just skip this step, right? You don't need them. Okay, so if we go to the periodic table here, and I think I have one. I have so many papers floating around, boxes of tests. So for those of you that don't get what I'm talking about, you're like, oxidation, who? We're looking here. Only for the metal do you need to do this. So when you have a metal, you always have to look your metal up. So I looked my metal up, and here it is, okay? And copper has more than 1 charge in its box, which means I will need parentheses after its name, always. Whether it's in a binary compound or non-binary compound, if your metal has more than 1 charge, you need parentheses after its name, okay? Yes? So now I'm calling this copper parentheses right now. That's where we are so far. Okay? Now, what I like to do, if there's only 1 charge in the box, like say, who only has 1 zinc? Zinc only has 1 charge in the box, right? Then you don't need the parentheses. You just move to the next step. Okay? All right. Again, when I say more than 1 charge, I mean more than 1 possibility. This Cu plus 2 isn't more than 1 charge. It can only be plus 2. But PT could be plus 2 or plus 4, right? Gold can be 1 or 3, okay? So that's what I mean. If it has multiple oxidation states, only your metal, you got to have the parentheses after its name, okay? Now, or next, you would name your nonmetal, drop the ending, and add I. I have a flow chart there, same flow chart we used in class. I think Mr. Cohn uses the same one, so you should be very familiar with that. So you're going to name your nonmetal, drop the ending, and add I. So this was with S, and sulfur's the weird one. We would call it sulfide. And if you drop too soon or drop too late, that's no worries, as long as you're close. Phosphide, oxide, fluoride, chloride, bromide, right? You name your nonmetal, drop the ending, and add IDE. Now, we got to deal with that parentheses. Again, if it didn't have the parentheses, you would not need to do the next step. We must figure out which copper charge it has in this compound. So we need to determine the charge on copper in this compound. So that's what we're going to do next. Again, if there's parentheses, if there's no parentheses, you don't need to do this. Okay? So determine charge on metal put in Roman numerals in the parentheses. Now, there's a couple things you need to recall about doing this. Number one, the metal's always positive, the non-metals are always negative. Okay? So remember, metal is positive, non-metal is negative. Always. Also remember that the sum of all the atoms in the compound has to equal 0. Okay? So also remember that I call it the subscript times, there should be a T there, the charge plus the subscript times the charge has to add up to 0. Okie dokie. You ready? This one's not so bad. It gets a little funky in a minute. You got that? I'll just write it up here. So CUX. What the heck? Copper has more than one charge. I don't know which one to use. But I know it's going to be positive, and I know it's going to be +1 or +2, because those are the choices in the box, right? So you should recognize you're either going to put a Roman numeral 1 or a Roman numeral 2 inside those parentheses. But you have to figure out which it has in this compound. So to do that, look up who it's with. Look up sulfur. Now, if we go to sulfur's box, it says -2 + 4 + 6. But I just told you which one you should use. Because the metal's always positive and the non-metal is always negative. So sulfur gets a -2. Okay? Now, the other thing I told you is that when you take into account the number of coppers you have and its charge and the number of sulfurs you have and its charge, they got to equal 0. So how many coppers do I have? How many coppers do I have? 1. The subscript is 1 if there's no number. So bottom times top, 1x. Subscript times charge, -2. Has to equal 0. So what's copper's charge in this compound? So this is copper, Roman numeral 2, sulfide. Okay? Copper, Roman numeral 2, sulfide. Name this guy. Name him. Name him right there. Go. Right now on your paper. You've got lots of practice you can do later with answers. Name this one. Who needs a reference table?
I do.
Kind of hard to do this without one, right? Anybody else need a table? Andy, you got one?
Yeah.
Okay.
We've done this one.
Anybody else? Okay. Yeah. Yes. Yep. Yes. No. 2. Yeah. 2x minus 6. You get that? Okay. Good. I'm doing, this got to be in Roman numerals. But I gave you FE203, not FE204. Okay?
You're just standing there, you're like,
I'm sneaky. Nick, what'd you call this? Not try. Why? Where are we doing tries? No tries. No tries. We're using parentheses and Roman numerals here. No prefixes. Okay? That's the problem. See, we name our metal. We name our metal. Where are we? We look up our metal. It has more than one charge, so we put parentheses after its name. You have to follow these steps. You can't make up your own rules. Then we name the non-metal, drop the ending, and add I, and determine what the heck we're putting inside those parentheses. Okay? So we named this metal, which I agree, where did it go, is iron. Okay, this metal over here, that's iron. Does iron need the parentheses? Does it have more than one charge in the box? Yes. Yay, it does. So put the parentheses in the box. Or put the parentheses there. Name the non-metal, drop the ending, and add I. So I agree it's oxide. But now we have to figure out what the charge iron has in a net compound. So we give iron the X. We look up oxygen. It's -2. Bottom times top, 2x. Bottom times top, -6, always has to equal 0. 2x equals 6, x equals 3. So this number goes inside here in Roman numerals, okay? Iron Roman numeral 3 oxide. One more, and then we'll move on to the next kind. Oh, okay, yeah. Go ahead. Awesome. Na3P. Oh, that's okay. Nope. Correct. I'm trying to trip you up on this one. Always ID. Okay? Other than the T should have been a D. Yeah. All right, Dylan, what'd you call this one, Dylan?
I call it sodium phosphide.
Sodium phosphide is the correct name. Well, what do you do with that 3? Nothing. You don't need it. This metal only has one charge in the box. There is no need for parentheses, okay? Now, I understand Nick's confusion because once you start learning about prefixes or remembering prefixes, you go crazy. You want to use monos and dis and tris and tetras and pentas everywhere. You do not. The only time you will ever use those prefixes, everybody, is here. When you have only 2 elements and they are both nonmetals. Okay? Right here, nonmetal to nonmetal. You name the first nonmetal. You name the second, I don't care really what order you do it in. The subscript becomes the prefix. Okay? Unless there's only one of it. You don't use mon for the first element. I'll explain. I'll walk you through some examples. Prefix means in front of the name. Okay? Then you name this, and we should write not mon. Don't use mon for the first element. You can use di for the first element. You could use tri, you could use tetra, you could use penta, hexa, hepta, octa, nona, deca. Do not use mon. We don't say mon carbon monoxide. They might in Jamaica, but we do not here. Okay? So no mon for the first element. Then you name your second nonmetal, drop the ending, and add IDE. And the prefix becomes the subscript. And you can use mon, subscript becomes the prefix. You can use mon for the second element. Okay? So, let's say we had P2O5. P2O5. Again, Only 2 capital letters. Is there a metal? No. You know metals are to the left of the stairs. Non-metals are to the right of the stairs. So P and O are real close to each other on the right of the stairs. So this is a non-metal, and this is a non-metal. And now is when we break out the prefixes. Only when there's 2 non-metals. That's it. Okay? That's it. And you do have to memorize the first 4 prefixes. Okay? So if there's 1, we use mon or mono. If there's 2, we use di. 3 is tri. 4 is tetra. For 5 and beyond, you can refer to table P for prefixes. Actually, as you know from organic chemistry, the prefixes in table P are for something different. They're for the number of carbons in an organic molecule. But they're the same in 5 and beyond. The first 4 are different. Okay, 1 for 1 carbon is meth. Right? 1 is the subscript here is mon. Those are different. Right? 2 for 2 carbons is F. 2 for a subscript of 2 is di. So the first 4 you got to know. 5 and beyond you can refer to table P because they're the same. Okay? So what do we call this? Did you name it yet? Or no? Diphosphorus pentaoxide. Okay? Diphosphorus pentaoxide. Diphosphorus pentoxide. You don't even need the A in there when it's O after it. We usually drop that A when the O comes after.
If you put in the A, is it wrong?
No, it is not wrong, as long as you're close. How about, try this one. O2F.
Mono in front of like fluoride, is that wrong?
Yes. It is. It's wrong. Mhm. What's wrong? You only change the ending of the first element, not the second. And you don't. Are you saying you don't know the prefix for?
Wouldn't it be di?
Dioxygen.
Dioxygen.
Yep, dioxygen. Monofluoride. Dioxygen monofluoride. Okay? Yeah? You're good with those? Now, whenever we do that, whenever I do this metal, non-metal, and then I go to the non-metal, non-metal, people always want to start using prefixes everywhere. Do not resist the urge. Only use prefixes when it's 2 non-metals. That's it. That's the only time ever you do that, okay? Yes? All right, let's do with this 3. What if you have 3 elements? Table E and find your polyatomics. That's what you need to do. So everybody right now flip to table E. There are basically 3 scenarios you can have when you have more than 3 and it's not organic. You can have a metal that's positive and a polyatomic that is negative. Now, when this situation occurs, it's a metal, right? You name your metal, then you got to look it up. Just like before. Add the parentheses if you need them. Okay? Then you name your polyatomic. You don't have to do any switching or, like changing the ending. You take the name of the polyatomic right off the table. Okay? And then you, if necessary, you find the charge on your metal and put it in Roman numerals inside the parentheses. Here's where it gets harder. This is as hard as it gets, I think. Okay, so I gave you this crazy one before. Okay? Obviously, we see 3 capital letters. So we are going to go to table E and look for something on table E that is also present in our compound. And I'll get table E up there for you. And probably you're a little familiar with this. Mine's a little different because I have the older table here, but does anybody see any combination of letters that's also in my compound? SO4, there it is, right here, SO4. It's down here and it's in my compound. So that's my polyatomic right there, right? I'm going to take its name and charge right off the table. This is sulfate, as somebody said, and it had a charge of -2. Okay? -2. Now, this is what's with it. So this is my polyatomic right here, correct? What's with it is my metal, copper. Everybody knows that's a metal. And copper, if copper only had 1 charge in the box, we'd be done. But copper has more than 1 charge. So we need the parentheses after its name. Now, what numbers am I allowed to put in those parentheses? 1 or 2. That's my choices. So if you get 8 here, you're wrong. Okay? You're wrong. Okay? Because here's why. It's the same idea. Right? Bottom times top always has to equal 0. But we have 1 copper that's X. How many sulfates do we have? Don't say 4. Good. We only have 1. What makes a sulfate a sulfate is S and 4 O's. This whole thing has a charge of -2, and there's only 1 of those. Okay? So we have 1 thing that's -2, and that has to equal 0. So copper's charge here is 2. This is copper, 2 sulfate. For the record, if you had more than 1 of your polyatomic, it would look something, pretend this can't ever be, but you would have parentheses around it with the subscript outside the parentheses. Then you'd have 1x minus 4 equals 0. And copper would be plus 4, but it can't be. But I'm just telling you. What? What do you want? You want this?
Yeah, but you put a 2 on the copper.
Yeah, but then it'd be copper 2. Still. This is, what I've given you, Robbie, is the empirical formula. If it was Cu2SO42, that would be the MOFO. Right? That would not be in simplest terms. Oh, by the way, there's 2 types of formulas, empirical and molecular. Molecular formulas are what I'm referring to as MOFOs. They are just the formula. And the subscripts may not be in lowest terms, but an empirical formula has it in lowest terms. Time out real quick, because this will only take 2 seconds. We'll pick up here on Thursday. Okay, we'll continue to, there's really no more naming, but we'll formula write and balance equations on Thursday. You could have 2 polyatomics. That's your second scenario. That's super uber easy. You know what you do? You take their names off the table. That's it. You don't have to do anything. You just name them right off the table. And one other situation. Do you know what it is? The situation that's missing? You could have a, hold on, I gotta put it some. You could have a positive polyatomic with a negative nonmetal. And then you get this name off the table. And then you name this, drop the ending, and add the only thing you ever add when you change the ending, IDE. Did I say anything about prefixes? Only when it's non-metal do you use prefixes, okay? All right. So first, we will learn how to go the other way. If I give you the name, you give me the formula. And we'll learn how to balance equations and the different types of reactions. Synthesis, econ, double replacement, single replacement. All right, guys. Have a good night. It's been a pleasure.